All right, 4, 5, we are going to deal with 2 by 2 matrices, their determinants, and their inverses. So for this section, we're only dealing with 2 by 2 matrices, and we're going to learn how to evaluate their determinants, which is a new vocab word we're going to learn about in this section, and we're going to find their inverse matrices, which is also something new here. All right, so the second objective, use those inverses, once we know what they are, to figure out how to solve matrix equations. So 2 big objectives today. Vocab, square matrix, multiplicative identity matrix, multiplicative inverse of a matrix, and determinant. Alright, so here's our skills check. We're going to be able to clean a lot of stuff up in this section, so just quickly run through this. Make sure you're keeping track of your negatives. Pause this for a second and answer these. Shouldn't take you too long. When you're ready to go, press play again. Alright, so a square matrix, first vocab phrase we need to learn. A matrix with the same number of rows and columns. So it kind of is exactly what it sounds like. Alright, it can either be a 2 by 2 or a 3 by 3, 4 by 4, but it's got to be square, not rectangular. Alright, now in algebra, we know the multiplicative identity is when we times by 1. Same thing for matrix, but if we had a matrix that was all ones and we multiplied, it would change our original matrix. The one that's going to keep us exactly the same is going to be ones on a diagonal going down like this. If we took any matrix and multiplied by this matrix, if it was a 3 by 3, or this matrix, if it was a 2 by 2, we would end up with exactly what we started with. And that's called the multiplicative identity matrix. Again, identity, we're staying exactly the same. You'll remember from the 0 matrix is the additive identity. So if we add, we want to be using all zeros. If we multiply, we want to be using ones on the diagonal. Okay, so we're going to use the multiplicative identity matrix to find out the multiplicative inverse matrix, all right? And so what that is it's the matrix that takes an original matrix and turns it into the identity matrix, the one with all ones, all right? So it might be easier to look at an example. We want to show that B is a multiplicative inverse of A. So if this is A, we want to figure out what matrix, if we multiplied times A, would end up with the 1, 1 on the diagonal matrix, the identity matrix. All right? And so this one, they said, let's test to see if this is the one that works. So remember how this works. We're going to take the top row, the 2 and the 3, and times it by the first column, the 2 and the negative 1. So 2 times 2 right here. That's 4, and then 3 times negative 1 is negative 3. Put them together, you end up with 1, so that checks out. We could keep going, 1 and 2, bottom row, and this would be our first column, would get us this section here. Multiply those together and add, we're going to get 0. And so it does check out. We end up with 1, 1 diagonal, and the rest are zeros. Now the one thing that we know is that if B is a multiplicative inverse of A, then it works the other way also. A is a multiplicative inverse of B. All right, so multiplicative inverses are commutative. They work both directions. All right, so your turn. Plug these in together. Make sure that the resulting matrix is ones on the diagonal, zeros everywhere else. Okay, so that leads us to their next vocab phrase, the determinant. All right, and the determinant is a number that we're going to use to figure out the matrix. All right, so the determinant, there's not a really great phrase for it, but the determinant is more defined by its formula, and the formula for a determinant is A times D diagonal down minus B times C diagonals up. All right, so you can see kind of the cross here. We're going to multiply A times D and then subtract B times C. So we'll see some examples here. What's the determinant of this matrix? Well, it would be negative 3 times negative 5. We list that here. Minus, now we're going to multiply up. 2 times 4. So negative 3 times negative 5 is 15. 4 times 2 is 8. We subtract, we get 7. So, and then they have 2 more examples of these here. 2 times negative 2 is negative 4. 3 times negative 3 is negative 9. Negative 4 minus negative 9 is positive 5. And then they have another one here with just variables. A times A is A squared. 0 times 0 is 0. Subtract them and you've got A squared. So, your turn. See if you can figure out the determinant of all three of these matrices. Be careful on the last one, C, and make sure you're putting things in proper parentheses and distributing correctly. Alright, so how do we find an inverse? Well, an inverse, if it's not given to us, is determined by this right here. The inverse of a matrix is 1 over the determinant times, take your original matrix. Take the A and D and swap positions. So this number, what used to be top left, put it in the bottom right. What used to be bottom right, swap it and put it in the top left. And then for the B and C, leave them where they are, but throw negative signs in front of them. Times that new matrix just by, it's a scalar multiplication, so it's just multiplying straight in by whatever 1 over the determinant is. So let's see some examples, see if this makes sense. So here we go. Here's our matrix. We want to find the inverse. So first thing we do is find the determinant. Negative 2 times negative 4, that's going to be 8. 2 times 5 is 10. So 8 minus 10 is negative 2. So our determinant is negative 2. Now we're going to swap things around. Negative 2 and negative 4 switch positions. So they used to be here. Now they're here and here. Negative 4 and negative 2 switch positions. 2 and 5, leave them where they are, but change the signs. So 5 becomes negative 5, 2 becomes negative 2. Now that's our new matrix multiplied by 1 over the determinant. And the determinant we got up here again was negative 2. So 1 over negative 2 times all of these numbers. What's negative 4 times 1 divided by negative 2? That's going to be positive 2. What's negative 2 divided by negative 2? Positive 1. Negative 5 divided by negative 2, that's 2.5. And negative 2 divided by negative 2 is 1. So that is our inverse. This final one here is the inverse of the original matrix M. Now the one thing, I didn't really say it, but right in here, if the determinant is not 0, then we have an inverse. If the determinant is 0, so that's why we do the determinant first, 3 times 6, 18. 2 times 9, 18. That's 0. There's no inverse. Okay, can't do it if the determinant is 0. So you're up. Here we go. A and B. See if you can find the inverse of each of these matrices. All right. Now, once we know how to use the inverse, or find the inverse, sorry, we can use the inverse to do equations. And so you can't just divide matrices. You have to multiply the other side by the inverse. Just like instead of dividing fractions, we can multiply by the reciprocal. Instead of dividing matrices, we can multiply by the inverse. So here we go. Let's take a look. We've got this matrix times x equals this matrix. So instead of dividing this away, which is not allowed, we're going to multiply the other side by the inverse. So we need to find the inverse here. So first step, we do the determinant. Negative 2 times 3, 1 times negative 5. That turns into negative 1. Okay, so this right here, they don't simplify it out in the book. I'm not sure why, but this turns into negative 1. So 1 over negative 1. And now remember, we're going to swap positions. So negative 2 and 3, we switch. So right here it's switched. 1 and negative 5 stay where they are, but switch signs. So 1 becomes negative 1, negative 5 becomes positive 5. 1 divided by negative 1 is just negative 1. So we'll multiply every number by that. 3 times negative 1 is negative 3. 5 times negative 1, negative 5. All the signs are going to switch here, 1 and 2. So here's our inverse matrix. And now we've got it on the other side here. So with the negative 2 and 2. And so now we just need to multiply these together. Negative 3 and negative 5 match up with this row. We multiply the corresponding elements, and we end up with negative 4 for the top. We're going to go bottom row times the column for this option here, and that turns into 2. So if we multiplied this times negative 4 over 2, we're going to end up with this matrix here. So x equals negative 4 and 2, that matrix. And it does show you that you can check. If we plug back in and multiply again, it does work out to be the same thing. So we could check. All right. So we could always do this on the calculator as well. You're going to have to be able to do this by hand, but I want to walk through how we would do it on the calculator. So let me bring up the calculator, and we'll go into the, come back. Where are you, calculator? There you are. Let's go into our matrix and go over to edit. And we've got a 2 by 2 and negative 2. Let me edit this one so we're doing the right one. Negative 2 and negative 5 and 1 and 3 and then let's edit B. So it's a 2 by 1. And we want, so this is going to be this matrix here. -2 and 2. I'm going to go out of here and clear it off so we can see it. So what we want to do, first we need to find the inverse of this and times it by this. Well, we can do that all in one fell swoop. But I'll do it piecemeal here so we can see each thing and make sure we're right. So let's find the matrix first, our first one. We want to do the -1, so that's right here. Put the -1 on top of it, hit enter. -3, -5, 1 and 2, checks out right there. Okay? And now to check at the end, let's multiply them together. So same thing. We want to do, again, the inverse of A. Now this time we want to times it by B. And there we go, -4 and 2, which is our final answer that we got here. All right, so we need to know how to do it by hand, but for a lot of the problems, to simplify and make it go faster, we can use our calculator either to do them or to check that we're getting the right answer. All right, so you're up. Here we go. Try A and B. Try at least one of these by hand all the way through. Check it on your calculator. And if you do it perfectly, feel free to use the calculator on the second one. If you have trouble, try to do the second one by hand all the way through. All right, and lastly here, let's see how this works in a real-world connection. So of the people that own a cell phone, 87% of them keep their cell phone the next year. Of those people that own a cell phone, 13% of them get rid of their cell phone for the next year. Of the people that don't own a cell phone, 57% stay in that situation. 43% of them get a cell phone. And so we could write that in a matrix here. No cell and no cell, 57%, that's here. Of the people that had no cell, 43 of them go and get a cell phone. And the same thing for the people that had a cell phone here. 87% of them stay, 13% of them change. And so we can use this as a prediction to figure out if we have 16,000 people and 99.27 own cell phones while 60.73 do not, we can figure out, okay, next year, how many of them are going to have cell phones and how many of them are not going to have cell phones by multiplying these two things together. Okay, and so if you do it here, you end up with these numbers. You could also go backwards. If we knew that these are our numbers now, how would we divide away? Remember, to divide, you'd have to use the inverse of the other one. So that would take us back to the year before of the people that. So last year, 9,000 people didn't own phones, and 6,900 people did own phones. So kind of use that thinking here to do the critical thinking on part or understanding check number 5. And that's it for 4-5. Any questions, make sure you're asking in class.